All right, guys, we are going to venture into something new with these systems. I know the whole chapter has basically been review, but now we're going to get into systems of three equations and three variables. So a little warm-up problem you could try here. Remember how to graph that absolute value. Remember the inside is left and right, and it's opposite of what we're looking at. So we know this one's going to go to the right 8, 2, 3, 4, 5, 6, 7, 8, and up and down. This one's true, up 3. And the absolute value gives you that V shape. That's why I say value kind of weird when we do talk about that. So quickly to review, not really dealing with what we're going to talk about today. So as you can tell, maybe I'm super excited about getting to this. All right, so what we're doing is we're going to put some points out in space, like these blues and reds, stuff like this. And I use the idea that if you set things up for a 3D printer, right, and each little dot that it makes is one little point there until we build something magnificent, then that's kind of what we're doing baby steps of. So this really works in the background of what's happening there. Other idea is that if you have three planes, right? So a plane, instead of being one dimensional where we have a line, it's the whole thing. So this whole green piece here, it cuts through this yellow piece, and we see that intersection happen right here. Okay, but then what happens after that is it's also being cut through by this reddish or pink one. So we're finding that one point that all these planes meet, and that's kind of what you're telling those printers to do when you're doing all those things. All right, now the steps, they're going to seem vague and very simple, although we're going to do a lot of work for this. But that's okay, because we have the capacity for work, so we're going to be able to get through this just fine. So what I want to do is I want to take a look at, and the first step does take sometimes the longest. Sometimes it doesn't, but I want to eliminate the same variable twice. So as I look at this problem on the left, I'm kind of looking at all the x's, all the y's, and all the z's, and I want to find out what's the easiest thing to get rid of twice. Okay, so as I look at this, well, I get z, 3z, and 2z. Well, I don't have anything that I can get rid of immediately, unlike y. I have positive y and negative y. And the other one is just 2y. And I have the same situation for the x's, so it really doesn't matter. If we were in class, we would do a quick vote. But hey, it's a video, sorry about that. So what we're gonna do is we're gonna identify and get rid of the x's just because it's on the very beginning. Okay, so one thing for taking care of the organization part of it is I like to identify what I'm going to do. So I'm gonna get rid of x twice. So that's my very first goal. So what I'm gonna also do is say this is equation 1, 2, and 3. So what I'd like to do is I'm going to take equation 1, which is x plus y plus z, and make it equal to 6. And equation 3, negative x plus 2y plus 2z equals 9. And since they're already opposites, I get to add them together. So there goes the x, add them together. So I get 3y, add them together, I get 3z, add them together, and I get 15. We're like, that's great, Mr. Tolo. I get rid of x. And then awkward pause, right? Because that doesn't mean anything. Remember, I have to do this twice. So I have to take another combination of my equations. And this time, I'm going to have to do something extra. So I definitely want to use equation number 2. So I have 2x minus y plus 3z equals 9. And if I want to get rid of this x again, I'm going to use the bottom equation and multiply it by what? By 2, right? So I'm going to make this negative 2x plus 4y plus 4z equals 18, right? And I chose equation number 3 because it was already opposite in sign, right? It was already negative. If I choose the top equation, multiply the whole thing by negative 2, that would work as well. So to me, we're going to give you a lot of choices here, but all your choices have those consequences. And remember, that doesn't mean it's a bad thing. Okay, that just means you have to do something differently after that. Again, we're going to add these together because we set them up to be opposites. So there they go. Now we got 3y plus, add them together, 7z plus, add them together, 27. All right, now we had something amazing happen here, which makes our life a little bit easier because I told you up front, it's going to be a little bit of work. So we solved two variable, two equation. All right, so this means we are up to the steps of all the things we just did. And what I have right now, let me highlight them so we can really focus in on. So I have 3y plus 3z equals 15, and I have 3y. Hey, look at that. I have a 3y and a 3y. So what I'm probably going to do at this point is take this one or that one. I'm going to multiply by -1. I chose to do that over here. So I'm going to use -3y minus 3z equals -15. So I can add them together one more time to get rid of y. That's what we were after. When I add these together, I get 7 plus -3. Well, that's 4 with the z. And 27 plus -15, I believe that's going to give me 12, right? And divide by 4. So z turns out to be 3. Bum, bum, bum. We have 1/3 of the answer. All right. Now, the other reason that I highlighted everything in yellow up here, these are my two variable equations. Those are my two choices to go back to. All right. I have some room under 3z plus 3y equals 15. So that's where I'm going to go next. So 3y plus 3, found out z was 3, so it equals 15. So now I can solve this for y. Why? Because I have to. All right, so 3y plus 9 equals 15. So 3y, let's subtract that 9. So we got 6. So y turns out to be 2. Well, that's fine and dandy, but I still need to know what x is. All right, so we have some choices. Way back when we started, I had equation 1, 2, and 3. Which one seems like the easiest one to plug in z is 3, y is 2 to find out the answer? If you're not saying equation number 1 right now, I'm worried about you. All right, equation 1 was x plus y plus z equals 6. Well, I don't know what x is, but I know y is 2 and z is 3. All right, so that's x plus 5 equals 6. We're going to subtract that and get x is 1. Oh, look at that. That's cute, Mr. Rotolo. We got 1, 2, 3 for the answer. All right, and what that means in the grand scheme of things, right, is this point right here is 1, 2, 3. So x, y, z. Because we can work things out in 3 dimensions like we see here with the red and the blue points. Okay. All right, so the idea is eliminate the same variable twice. Okay, so we're going to be very intentional. Just to review what happened there, I'm going to identify what I'm going to eliminate twice. In case something strange happens, I want to make sure that I stick to that plan regardless of what happens after that. All right, so let's try that again. Remember, our focus in the beginning is really just about what's the easiest thing to get rid of twice. All right, so I got 1, 2, 3. Not bad. 1, 3, 5. Okay. And I got 1, 2, 4. All right, so there's nothing that's overwhelmingly easier. Like last time I was looking for a positive x and a negative x. So I think for this one, again, if we were in class, we would totally talk about it. But I think here, just because I have the negative on the y, and I don't like to add extra negatives in there, I'm going to go after y this time, and we'll see what happens. I'm going to talk about this as equation 1, 2, and 3. Now, the problem is I don't have any equations where it already matches up. So what I'm going to do is I'm going to use equation 2. So 2x plus 3y plus 2z equals 2. And what I'm going to do to the top equation, right, so that I get my 3y's to match, is I'm going to multiply by 3. So I get 3x minus 3y, that's a good thing, plus 3z equals 18. All right, so remember to distribute that 3 the whole way over to the 6. All right, so I have my first equation to work with. I have -3 and +3, so they're going to eliminate. That's what we wanted. So I get 5x plus 5z equals 20. That's not too shabby. All right, let's try this again. Remember, my goal still is to eliminate y twice. So this time, instead of multiplying by 3, right, because I need to work with this third equation now, 3x plus 5y plus 4z equals 4. And I'm going to go back to this first equation because it's so easy to manipulate because all the coefficients are 1 or -1. So if I have 5y, I want to multiply by 5. So eventually I have -5. All right, so 5x minus 5y plus 5z equals 30. And we'll add these together and eliminate the y value. 8x plus, all right, these are going to add up, 9z equals 34. Okay. Not our favorite equation to work with, but definitely something we can do. All right, so I have x's, I have 5 and 8. I have z's, I have 5 and 9. All right, hold on. Take a look at this other equation over here, 5, 5, and 20. What can I do to this whole equation? Yeah, let's divide it by 5. So I have x plus z equals 4. And now all I have to do is multiply this one by either -8 or -9. So I'm going to use -8. So -8x minus 8z equals -32. Oh, I like that strategy. We're able to get all those coefficients down to 1, so I don't have to multiply both of my equations. Because we already agreed this is going to be a little more cumbersome. There's more work to it. Okay, x's are gone. I got a z and it equals 2. All right, well, if I got z equals 2, you know where I'm going. Right here. So if z is 2, x plus 2 equals 4. So x is 2. All right, and remember, out of our original equations, I do want the easiest thing there, which happens to be that first equation we kept working with so much. So what do we know so far? X is 2 minus y. Z is 2, and it equals 6. Oh, boy. You see what happens here. All right, negative y plus 4 equals 6. Subtract the 4. So I get negative y equals 2. So y equals -2. And we do want to write it as the ordered triplet here. So we got 2, -2 for y, and z came out to +2. That way your old math teacher can find the answer. All right. So we got our third example here. By all means, if you think you know what's going on, then you can pause it, fast forward, and kind of see what happens. Remember, we're always talking about these as equation 1, 2, and 3. We're looking vertically. So I got 1, 2, 4. I got 3, 3, and 3. I got 3. Okay. So if you didn't pick y on this time, then I'm worried about you. All right. So I want to get rid of y. Let's use maybe the top two here. X minus 3y plus 3z equals -4. 2x plus 3y minus z equals 15. They're already opposite signs, so we're really liking this problem. 3x, all right, we got rid of y, we got plus 2z, it equals 11. So that's a pretty good equation to work with. Next thing I'll do is I'm just going to take these bottom two the way that they are and add them together. So to save us some space, same thing for you guys, let's add them together. I get 6x. Get rid of those. Got rid of those. Oh, and we're going to add these together. So 15 and 15 is 30. So this is what, 34? All right. So that's not as good, but we'll make it work. So x turns out to be 34/6. We're going to have to reduce that just a little bit. Oh my goodness. I really wanted to get rid of those, but I couldn't, could I? All right, sorry about that. What happens here? -2z, and then I get the 34. All right, I really wanted those to be opposites, but then when I started thinking about it, I was like, no, they're not, are they? All right, so hopefully you're writing with your stylus, not on paper there. Otherwise, I blabbered on so you get erased. Oh my goodness. All right, so my bad thing was a good thing in the end, right? Because here's my two equations. They both have x and they both have z. So that means I can work with this. I'm just going to bring this one right down here. 3x plus 2z equals 11. And you're saying, well, why didn't we do something else with it? Right? What'd you notice about the z's? I got 2z and -2z. Boom, here we go. 9x. Those eliminated. It equals, hey, this looks a lot better, right? 45 divided by 9. X is 5. There we go. All right, if x is 5, this equation right over here has some space, and the numbers are smaller than the other one. So 2 good reasons to use this one. All right, so I get 15 plus 2z equals 11. Let's get rid of that 15. So 2z is -4. Z turns out to be -2. Now I need an original, and none of these are super duper better than the others. So we just have to make a choice. All right, I get double negative and 3. I don't like that. I don't have a coefficient on this one, so I don't like that. So I'm going to go to equation number 1. I mean, a little more space here. All right, so x is 5 plus -3y plus 3 times -2, and it equals -4. All right, so I have some space here, so that'll work. All right, I get 5 minus 3y minus 6 equals -4. So I get -3y minus 1 equals -4. I'm going to add the 1 to get -3. So y turns out to be 1 when we divide. All right, so we get 5, y was 1, and z, you were -2, so that those work out. All right. So just be careful as you read those signs. All right, you saw I had a little hesitation in there. So make sure if we're adding those together, that becomes -2. All right. Let's try one more, and then I think that's good for this video. So again, equation 1, 2, and 3. What are we going to get rid of twice? 6,5x, 421, 52, and 1. So again, there's really no reason to pick any one in particular. The only thing I could think of is the -4y has a negative sign, but it makes no difference at all. So partially for that reason, I'm going to go ahead and go after the y value this time. So again, I want to know what I'm going after so I don't lose track of what I'm doing. But for the most part, I'm going to use equation number 3 on all these. So let me get 5x plus 2y plus 2z equals 13. And bottom equation, if I'm going after y, I'm going to multiply by -2. So -2x minus 2y minus 2z equals -4. And then we get to add them together. So we get 3x. I'm double check my signs. Oh, this one is gone. And it equals 9. So x turns out to be 3. Awesome. So does that mean I can go back in and just fill in x is 3 right here and be done? No. No. That's why that's what I thought was going to happen in the other problem, but it didn't. So what we need to do now is stick to the course, right? The idea is I have to get rid of y twice. So we still have to do that again using a different combination. So I'm not going to multiply by -2 this time. Maybe this time, since I'm going to use equation number 1, I'm going to multiply by 4. So I have 4x plus 4y plus 4z equals 8. And I'm going to bring equation 1 down here, 6x minus 4y plus 5z equals 31. And we are going to add these together. I get 10x. The y's go away. That was our overall goal. Plus 9z equals 39. All right, now here's the only shortcut we can get based on what happened in the blue ink over here. We know that x is 3. So now it's 10 times 3 plus 9z equals 39. So even though I was able to eliminate y and z, I still need to get the other equation down to 2 so I can solve for 1, right? Because I can't have two unknowns in one equation. 30 plus 9z equals 39. All right, so 9z, subtract the 30, we're down to 9. So z turns out to be 1. And my hope is that you see this bottom equation. It's the easiest one to work with. All right, so I know x is 3 plus, we don't know y yet, plus 1, it equals 2. So y plus 4 equals 2. So y is -2 when we subtract that 4 out of there. All right, so we got 3, -2, and 1. All right, so these are going to take a little more time, a little stamina we need to work through the whole problem. Remember, we're after what's the easiest thing to get rid of twice. And then stick to that plan, even if we get rid of everything like we did over here.